Wow, it is exciting to see you guys live. In 3D, you have legs. That's exciting. It sure beats talking into a camera that we've been doing for the last 2 years. Hey, so we've been investing a lot in innovation. Unlike some legacy competitors that seem to be investing in advertising around our conference venue. It seems they are not able to get customers to their own conference venue, but we'll leave it at that. We have so much innovation packed. In fact, the platform has grown massively, and we've been constantly adding features and enhancements. We couldn't possibly deliver all the things we wanted to show in a day, so we decided to break the keynote into 2 parts. You're going to see part 1 today, and then we'll have another version 2 tomorrow. But before I get started, we are a public company. I want to remind you, we will be making forward-leaning statements, and so safe harbor applies. With that, are you ready for some exciting Zscaler innovations? So Jay covered a bit of our vision and mission, but just to reiterate, from day one, the Zscaler mission has been to make the internet safe for businesses and enjoyable for users. And fundamentally, our architecture has always been based on zero trust. And when you look at zero trust versus traditional castle and moat security, traditionally network-centric, firewall and VPN-centric, there are 3 fundamental principles that we've used over and over again. The first, and Alex talked about it, is we always want to decouple application access from being on the network. So users, workloads, they're always decoupled from the underlying network, and that prevents a lot of the lateral movement risks that we see. Second, because all your assets are behind Zscaler IPs, the rest of the world sees a very, very limited attack surface, and that, again, cuts down your business risk dramatically. And finally, the most important, we use a proxy-based architecture with full inline SSL scanning capabilities. And again, you saw from Alex, most of the content that we see today is encrypted, and unless you're scanning that inline, you'll be blind to most of those threats. So we use these principles over and over again in everything that we do. Now, most of you have used Zscaler Internet Access and Zscaler Private Access, largely for your users and employees. When your employees want to connect to internet and SaaS applications, they go through Zscaler Internet Access. We make sure nothing bad comes in, nothing good leaks out. When users want to talk to internal private applications, they go through Zscaler Private Access. And we do that using the same zero trust principles. And then, because we're sitting in line with all that traffic, it's our job to deliver an outstanding user experience by making sure that we are as close as possible to the users and as close as possible to the applications that they're trying to access. Those same concepts are now being extended to workloads. Why shouldn't workloads communicating to the internet go through ZIA? Why should 2 workloads that need to talk to each other be on the same network? Why can't we still have the same zero trust connectivity principles? But workloads also add an additional angle. You have to secure their posture. And we're going to talk a lot about that today. And finally, extending that to IoT and OT environments is a natural extension. When you want to talk to IoT devices, why should I VPN into the network? Why should telemetry information from my OT environments require a flat network again? So we're looking at our core Zero Trust Exchange, trying to address all of these use cases in a secure and fast manner. So what is Zscaler for Workloads? It starts first with posture control. And what is posture control? Let me give you a couple of simple examples. You might be adopting a cloud-native environment. Let's say you have an Amazon S3 bucket for storage. You want to make sure that it's configured correctly. It's not exposed to the world. Who has access to it? What kind of entitlements exist around it? These are important questions that you need to lock down. We also know now that a lot of infrastructure is code, IAC. If your templates themselves have issues, you will be setting up infrastructure that is insecure by design. So you want to lock down all of those templates early on. Then you get to exposure scanning. Let's say you have a AWS EC2 instance. You want to make sure that it's not exposed to the world. But further, you're curious about what is running on that compute instance. Does it have vulnerable software on it? Does it have access to sensitive data? And making sure that all of those things, the posture, the configuration, the entitlements are tightly locked down is very, very important as step one for your cloud-native environments. Now, once you've done that, you move to workload communications. Your workloads need to talk to the internet. If a workload is downloading some software from the internet, you want to make sure that it doesn't have malware in it. Your workloads might be accessing APIs. How do you make sure that that's all secure? You want to make sure workloads don't exfiltrate data onto the internet. And similarly, when workloads talk to each other, just like your users access private applications, workloads talking to each other should be doing that over ZPA with zero trust principles that are based on identity and not being on the same network. We call all of this Zscaler for Workloads, and it's designed to provide end-to-end security for your cloud-native environments, all the way from build time to runtime. Now today, we're very excited to launch Posture Control. And to give you a deeper view and a demo of its capabilities, I'd like to now invite Rich Campagna, SVP of Product Management.
Sure. Thank you, Amit. Posture Control is a cloud-native application protection platform, or CNAPP. The product combines several risk identification engines to create a powerful platform that helps organizations like yours build and run secure cloud applications. Importantly, this product will allow your InfoSec teams to more efficiently mitigate public cloud risks and collaborate more effectively with their development and DevOps counterparts throughout the organization. The foundation of Posture Control starts with configuration scanning. Configuration scanning looks at the infrastructure and services that you deployed across a multi-cloud estate, including every major cloud provider, providers like AWS, Azure, and GCP. Configuration scanning identifies things like misconfigurations, excessive entitlements and permissions, compliance issues, and more. And importantly, it takes those capabilities and extends them across the cloud application lifecycle, allowing you to identify these weaknesses as early as possible. On top of that foundation is exposure scanning. Exposure scanning is looking at the individual applications and data that you've deployed across your public cloud environment, identifying things like exposed attack surface, unpatched vulnerabilities, and sensitive data. All of these are critical inputs into the risk calculation that you need to make when determining whether or not there's a certain incident or certain weakness that you need to mitigate. So at the heart of Posture Control is a powerful risk correlation and prioritization engine. This engine understands the relationships between assets and a broad range of signals that have an impact on security of your public cloud environment. It provides both proactive and reactive capabilities for your team to securely deploy cloud. So proactive capabilities identify the combinations of weaknesses and risks that are most likely to be exploited in your environment, leading to a security incident. And reactive capabilities are provided by a powerful cloud XDR type function that allows you to identify even complex multi-part security incidents. The system, or the output, is a complete view and prioritized view of your organization's public cloud risk. And this acts as your team's starting point for efficient response and remediation across your entire multi-cloud estate. So let's drill down into a simple example: inbound traffic from unknown malicious IP. If we see something like this in any of our environments, certainly we want to respond to it as quickly as possible. Now, of course, we can easily leverage some sort of runtime protection control, such as Workload Communications that you'll hear about from my colleague in a few minutes, to cut off that traffic. But in addition to taking that action, we want to ensure that we understand what happened, what are the sequences of things that led to this event, and how do we prevent this type of thing from occurring in our environment again in the future. So if we were to task our SOC team with investigating this incident in posture control, you'll see at the center of this incident is an EC2 virtual machine. Very common deployed asset across most of your environments in the public cloud. And that virtual machine has a couple of high-risk, high-severity vulnerabilities associated with it. And so the question is, looking at an incident like this, how would you have known that out of the thousands, if not more, of similar vulnerabilities that are across your public cloud environment and across your organization as a whole, that these ones were important? Well, the answer is that it depends. If this particular asset was air-gapped with no access to the internet and no access to sensitive data, there's probably not a lot of risk here. Even if this is a big, major, and important vulnerability like Log4j or something similar, this may not be something that your team chooses to prioritize. But if, on the other hand, you understand the relationships between this asset and the rest of your cloud deployment, the picture becomes quite different. So in this case, this asset has access to a sensitive data store that contains customer personally identifiable information. Immediately, the risk profile of these vulnerabilities has changed. Now we're talking about something that has potential to do a lot of damage in our environment. If we zoom out even further and look at the full scope of the incident, in addition to these unpatched vulnerabilities and this access to sensitive data, you see a couple of other critical issues as well. First of all, we have a user. We've hidden his true identity. We'll call him John Smith. And John Smith has access to a role that gives him excessive permissions inside of, in this case, this AWS environment. Now, analysis by posture control determined that nobody else in John's cohort had access to this particular role and this set of permissions. And at the same time, these permissions were abused by John to make a change to this environment that we'll talk about in a second. The other issue that is pretty obvious here is that we have a security group misconfiguration that has exposed this asset to the internet. So we're getting a more and more complete picture of what has happened here. We have this asset, has access to sensitive data, is exposed to the internet, and we have this connection from malicious IP. So on their own, each of these may not represent a lot of risk to the organization. These are minor weaknesses, minor events. But together, they've exposed a sequence of weaknesses that potentially allow attackers to compromise that sensitive data, and potentially even a lot more than that. So we've built out our timeline of how this transpired. The endpoint here was connection from malicious IP. We want to stop that as quickly as possible. Once that's done, we work backwards, go back to the beginning, and look at what happened. Well, what happened was John Smith abused that excessive permission that he was assigned to modify security group ingress rules against company policy. That event is what exposed this asset to the internet, even though it shouldn't have been exposed to the internet. A short while later, this agentless vulnerability scanner that we have developed as part of posture control identified those high-risk vulnerabilities. It's continuously taking snapshot-based scans of every asset across the environment, and those vulnerabilities popped up a short while after that. Then we saw reconnaissance, external port scanning, and this finally culminated in connections from this malicious IP as determined by Zscaler Threat Lab's threat data. So if you were to try to piece this together using separate point products, which probably many of you have in your portfolios today, this would be difficult, if not impossible, and of course, incredibly time-consuming. So posture control consolidates cloud security tools like CSPM, CIAM, vulnerability scanning, and many more into a single platform. Now, in this case, there's a happy ending to our story. The SOC team was able to detect the malicious IP connection as it happened, and no data was compromised. But wouldn't it have been better to have prevented this incident altogether by determining where these weaknesses were and eliminating them prior to deployment to the public cloud? So posture control extends these risk visibility and prioritization capabilities across the entire cloud application development lifecycle. We do this via native integrations into the workflows that the development and DevOps tools in your organizations are already working with. Integrations into the most popular IDEs, source code management systems, and DevOps tools. And the objective is to allow the security team to collaborate as effectively as possible with their development and DevOps counterparts. So in an ideal world, security team sets the policies and determines when and where to enforce those policies. And their counterparts identified and fixed those issues, those policy violations, in the same tools that they're already using, without having to switch contexts, without having to learn a new security tool, and probably without having to interact so much with the security team altogether. So let's take another example here. In this case, we have a very simple policy. We want to ensure that encryption is enabled for elastic block store volumes. This is a popular storage service in AWS used by EC2 instances. Everyone that's using AWS has this particular service deployed somewhere in their organization. So very easy policy. If I'm a developer, and I'm operating, in this case, in Visual Studio Code, and I'm creating a Terraform template here, I want to know exactly, as I'm writing that code, where the policy violation is, what I need to do to fix it, and why this policy violation is important so that in the future, I learn from this situation and don't create these kinds of issues again. So with native plugins into tools like this, the developer has everything they need to resolve that issue without interrupting their workflow and without switching application contexts. Another example, this is GitHub. In this case, the organization has put a gate in place. So we're looking for the same policy, that elastic block store encryption. But in this case, there's a specific gate the organization has decided to put in place. So this is about where and when the security team can enforce these policies. And specifically what they're doing here is they're not going to allow this pull request to continue unless the EVS volume in question is encrypted as per policy. So you've identified these issues. You've infused them directly into the workflow that these developers and DevOps teams are already using, and you allow them to solve them right in line. So these examples are just a fraction of the powerful capabilities provided by Posture Control. So the platform allows you to secure cloud assets, building a comprehensive inventory of everything you have running in the cloud and identifying all the misconfigurations across hundreds, if not thousands, of services across your multi-cloud environment. It allows you to identify excessive permissions and entitlements and drive towards least privilege for not only humans, but for the services and other assets running across these public cloud environments, a really big part of the security posture of your cloud environment. It offers continuous compliance. So this platform is backed by Zscaler's cloud security threat research team, who are constantly analyzing the latest cloud threats and are looking at the evolution of hundreds, if not thousands, of cloud services and taking thousands of policies and mapping them proactively to a broad range of regulatory frameworks and industry frameworks. So things like CAS, NIST, GDPR, HIPAA, et cetera. This allows you to ensure you know exactly where you are from a compliance standpoint at any given time, even though your cloud environments are heavily automated and have a lot of users that are driving into it. Shift-left security, as I talked about, enabling effective collaboration with your development and DevOps teams in the workflows that they choose to work in. And then agentless vulnerability scanning. This allows you to identify vulnerabilities in any container or VM workload without any agent deployment or any challenges with rolling out some of these capabilities across the environment. So 100% coverage for any workload that you've deployed into the cloud. And of course, as I've talked about, correlated threats to help you prioritize risks and incidents. So the platform is generally available. We're going to be featuring this in several breakout sessions and, of course, demo pods. Throughout the show, we have a number of product experts on hand, so I hope you find some time to either attend one of those breakout sessions or stop by in the expo and see a demo of the capabilities. So with that, thank you very much for your time, and no more slouching. Thank you.
Thank you, Rich. Show of hands. Was that good? Are we in the right direction? Awesome. So, once you've locked down posture, the next step, of course, is how do these workloads communicate? And how can I use ZIA and ZPA to securely make these workloads communicate with each other and with the internet? Let's take a look at how a legacy connectivity is set up for these cloud-native environments. Generally, it's based on a hub-and-spoke network. You have your data centers and branches that were connected, and now you need to extend that network to your cloud-native environments in Azure, AWS, and GCP. And you can see how messy it can quickly become. Why is that? That is because, again, you're extending a routable network. you're setting up a lot of virtual firewalls. If you zoom in to any particular VPC, for example, we're looking at this AWS VPC. You might have a production VPC inside. You might have a development environment. Maybe this VPC needs to talk to the internet. Well, you need to go through a transit gateway. You might have set up an internet VPC with some virtual appliances, virtual firewalls there to access the internet. Maybe your workloads need to talk to workloads that are sitting in your data center. To do that, you might have a north-south VPC with more virtual firewall appliances there. And quickly, you can see how unmanageable and complex it gets. There's a lot of VM bloat. The attack surface, which was traditionally contained to your data center, has now just exploded and is all over. And the one thing I've always learned in the security business is complexity is your enemy, right? The more complexity you have, the higher the probability that you will have an issue. How does Zscaler address this? Now, the same zero trust connectivity principles that we leverage for users are now available for workloads. With Zscaler Zero Trust Exchange, you can drop simple connectors into your branch, into your data center, into your cloud-native environments, and we offer the same zero trust connectivity based on identity and not by extending a flat network. So if you now zoom in to a VPC, the same VPC that I showed earlier with a legacy connectivity model, you can see how simple and elegant this is. You have your production environments, you might have a development environment, and you have a simple security VPC that is running Zscaler connectors. These connectors allow bidirectional communication, leveraging ZIA and ZPA as the exchange, and you can access the internet. So when workloads access the internet, they get the same protections that your users have enjoyed. Right? You make sure that nothing bad is coming in, nothing good is leaking out. When workloads need to talk to other workloads, they don't need to be on a flat routable network. They communicate through the Zero Trust Exchange and ZPA. And this is available today. Many, many customers are trying it out, and I'd encourage all of you to take it for a spin. The other component of workload connectivity is how do we make your branches and data center connectivity simpler? Now, Jay shared this slide earlier, so let me double-click and take it a little deeper. Now, traditionally, if you had branches, what you did with Zscaler was you set up a GRE or an IPsec tunnel from that branch to Zscaler, and that was primarily for your outbound traffic going to the internet. Any user, any devices in that branch got all the ZIA protections, but these branches also potentially had devices, printers, weighing scales, kiosks, other devices that needed to be managed, and there was no inbound connectivity. So in a branch like that, traditionally people have had an internal backhaul back to your data center, and you can see that causes problems because as soon as you have one infected machine in that branch, you still have that flat lateral network where threats can propagate. So what we're doing now is we are introducing simple branch connectors, and these branch connectors allow bidirectional communication into your branches and into your data centers, leveraging ZIA and ZPA. So you don't need to have any backhaul for some legacy devices that might be sitting inside that branch. It is fully managed by Zscaler. It's elegant, and it allows simple, seamless connectivity across all your branches and your data centers. We've always had option 3, which we've called the Starbucks-only branch. These are light branches. It could be your home office, where you simply deploy Zscaler client connectors on the devices, on the employee devices, and you get connectivity through ZIA and ZPA. So 1 and 3 have always existed, and now we're doing early preview access to model number 2, a simple connector for your branches that allows bidirectional communication through ZIA and ZPA. And to give you a deeper view of our workload communication solutions, I'd like to now invite Dhaval Sharma, VP and GM of Product Management. Rahul.
Good morning, and thank you, Amit. So, all workloads, right, whether they live in your data center or in public cloud, are communicating somewhere. Workloads are either going to an internet destination or they are going to a private application. And you need to make sure that these workloads are protected against downloading anything bad or uploading something which is really important for your organization to the data protection framework that we have built. Also, you want to make sure there's a lot of talk in the industry about segmentation, right? Getting the right segmentation framework going. So what we are able to achieve, leveraging our ZPA platform that we have built as the concept of a broader macro segmentation. As you move your workloads to the cloud, as they live in data center or in the branch, you want to make sure they are talking to the right set of other applications, workloads, and they are not open for anyone to be exposed on internet or from an outside-in perspective. Another thing that you want to make sure is when you are thinking about micro-segmentation, you layer it in on top of the macro-segmentation framework. And then for really critical applications, you can build deflection for your key application by emulating those softwares or applications by using our deception technology to protect your highly important and assets, which are your crown jewel applications. So all of these security capabilities need to be stacked in, layered in, and we are giving them to you as a platform and not as an individual point product. Now let's walk through how our customers are setting up this infrastructure, right? How do you set up, Amit talked about cloud connector, branch connector. From our perspective, this is the same software stack which is built to provide and cover different set of use cases. When you think about your branches and your workloads in the cloud, all of them as a network tech operator, as a security operator, you want to make sure you have a single pane of glass. So with our platform, what you're able to do is you are able to see all your cloud VPCs, your VNets, you're able to see all your branches through a single pane of glass. So in this case, if I click on any of these cloud locations, for example, you can see a bunch of VNets in Azure, you can see branch where we have deployed branch connector, you can see how they are communicating to which parts of your network. You can also see a full detailed view of all the branches and cloud workloads where they're running, and then you can define policies around it. Now, a lot of you who have been operating ZIA, ZPA, ZDX, you know that our policy framework is very criteria and action driven. So we have a set of criteria, rules around which you can define access policies. We are taking the same framework and making it just a simple feature that you need to enable for your workloads and where they go. So typically, when you define the forwarding rules as a overlay zero trust architecture, you can say that certain VPCs are going to the internet, here is the policy. Certain applications only talk to a certain segment of your applications, or a VPC can only talk to a production VPC or to another data center-based segment. You can define app-to-app segmentation policy. And sometimes you want these applications to go direct to internet. You just want to log what is the internet traffic going out, and you don't want to take action on it. So all those traffic forwarding rules could be set up with just a click of a button in the forwarding console that we have built. Now, if you want to set up an access policy, if you use our ZIA product, one of the criteria is location. If you have enabled cloud connectors, all your cloud VPCs, VNets will start showing as a location. So you can define very simple access policy saying, here is a list of whitelist destinations where these applications can connect. Likewise, if you use ZPA, we have the concept of app segmentation. Those segments could be defined based on these cloud locations. One of the things that happens as a result of it, these VPCs and VNets or branches or data center segments that we are creating become a criteria in ZPA policy. So you really do not need to recreate a new policy framework, deploy new set of infrastructure in order to protect your application. A lot of you are already protecting your application traffic coming to us from your data centers by sending traffic through GRE IPsec. Now what we are saying is you don't need to do that. You can actually create strong overlays by setting up this or extending this connectivity to the cloud stack as well. Now let's take an example of an application. Typically, we migrate applications to the cloud. Here in this example, we are talking about an intranet application which was running in our data center. We are moving it to AWS. Now, in the ZPA app-to-app segmentation policy framework, what we essentially are doing here, we are saying this internet application, which has moved to a cloud VPC in AWS, can talk to a couple of other VPCs in AWS, or to a PaaS service or a data store in Azure, and it can also talk to a data center or a branch location where you were running this application as a backup. So instead of opening this application to exposure to the entire world, you are making that application accessible only where it should be accessed from. So very simple policy, leveraging the same framework that you're familiar with and all the logging that you're familiar with in ZPA, ZIA. Just new set of attributes gets introduced based on which you can get this data out, integrate with your SIEM and SOAR workflows that we already support, and you can see that new client types get introduced like branch connector or cloud connector, and new locations which are tied to the VPCs and VNets that we are now organizing and bringing together. Let's take a second example, right? When applications talk to each other, you also want to make sure they're secure. A common example is a application which is exposed to internet, right? And it's talking to a lot of application data stores within your network. You want to make sure that application is not, or someone accessing that application who has administrative access to that application is not able to exfiltrate data from that. So what we're going to do here is the same application that we were talking about, the internet app, right? We are going to put web application firewall rules to block a SQL injection attack. We recently introduced the concept of inspection, which is basically taking the web application firewalling control, OWASP top 10 vulnerability control in the ZPA data path. So what we are doing in this case is when you set up application segments in ZPA, right, you can choose to inspect that traffic and then terminate that traffic and look at any vulnerabilities inside that. So in this case, what we are saying is essentially allow the cloud connectors from this location to access that application. And I'm using a vulnerable application or a front end to exfiltrate and enumerate a lot of data from a web database to basically get all the employee records and populate it here. So the moment you do that, basically I'm using a SQL injection as an attack vector. And if I have enabled the inspection, let's say this attacker is trying to exfiltrate this data using a web application front end, that will get blocked straight away. And even if they're using APIs or they are using any form of command line tools to get access, even that will get blocked. In your ZPA dashboard, you will start seeing the blocks that we are implementing as a result of this WAF being implemented. So what you will see is the same inspection policy implemented in the same logging framework, and that will also show you basically what inspection profile picked up, SQL injection was blocked, and which application that was targeting. So very, very easy way to implement a inline blocking for application which is talking to another application and blocking access to data exfiltration using SQL injection. Let's talk about a second use case, right? The same attacker, let's say if this access gets blocked, is now trying to exfiltrate data using FTP, right? So all of you are familiar with the DLP or data protection capabilities that my colleague will talk in a few minutes about from now. We have a lot of inbuilt engines. One of the engine is Pci Engine, right? So what we can now do as a result of this policy with Cloud Connector being enabled in the ZIA policy console is we can say, if the traffic comes from these specific VPCs or VNets of branch traffic, they become a criteria in the same policies. And then when a user is trying to exfiltrate data, you can see the FTP session is not getting established. And in the ZIA logs, you will see that the DLP policy kicked in against a VPC location, not a user, and at that time, the access was blocked. So full inline control with our web application firewall, we were able to demonstrate to you how data exfiltration could be blocked. And all of this is built as a capability on the core ZIA ZPA platform. And together with what Rich was talking about earlier, posture control, which gives you a lot of control around the shift left side as you bring applications to the cloud, as you operationalize them, You get all the benefits of configuration scanning, exposure scanning, and reducing your attack surface. And then as you operationalize these workloads in the public cloud, we also want to make sure that you have the runtime security for that as well. With that, I'll pass it back to Amit to walk through the rest of the innovations. Thank you.
Thanks, Dhaval. All right. So switching gears, we do all of this for security, but what is it that we're really trying to do? At the end of the day, we're trying to protect data and our crown jewels, right? And if you look at data from a user's perspective, users want to share, they want to collaborate, they want to have easy access to data, and they want to be productive. Now, if you look at it from an IT perspective, they want to control that data, and they want to have frictionless security. I really like that term, right? You want to be able to control, you want to be able to secure it, and you want to do it frictionlessly. At the same time, your users want an awesome user experience. So how do you balance those opposing forces, right? Where you want to enhance collaboration and user experience, but you also want to make sure that your data is protected. And we've done a ton of innovations in data protection. To give you a deeper view, I'd like to now invite Moinul Khan, our VP GM for data protection. Thank you.
Thank you, Amit. Good morning. During the next few minutes, I will do a quick demo. I'm going to walk you through an admin's day in the life with Zscaler DLP and CASB. So let's get started. Everything starts with visibility. You can secure what you do not see. First, we would like to explore what our users are doing when they're using these cloud applications. When I click on the Zscaler SaaS security report, it is telling me that in the last 7 days, our users used 352 applications. And 300 applications are not corporate approved. More interestingly, they're using a lot of cloud storage and file sharing applications that are not corporate sanctioned. And I'm worried because most likely these applications are hosting our company's sensitive data. So let's dig deeper. I can see our users are using applications like OneDrive and Salesforce, Box, and Dropbox, which is OK. But all of a sudden, I see this application called ZipShare. And I know nothing about ZipShare. The SaaS security report is telling me that it is a cloud storage file sharing application, but the risk index for this application is pretty high. Why? Because this application has poor T's and C's, and it also has a lot of security vulnerabilities. And yet, more than 300 users are using these applications, and I'm also seeing a lot of data movement. There is a lot of upload happening in this application. So now I have a decent amount of visibility about cloud applications. Which applications are here, what risks they're introducing in my organization, how my users are using this application, what is going up, what is coming down. That's all great. But what about the data? Can I get some more insights into my data without going through any complex DLP rules, regex, and policies? And then the answer is absolutely yes. Starting in release 6.2, Zscaler DLP is going to do data classification automatically using heavy AI and ML. We are going to be able to put all these sensitive documents, whatever we see inline and data at rest, into different thematic document categories. So now with that feature in place, when I go to DLP dashboard, it's telling me that in the last 7 days, more than 8,000 sensitive documents being uploaded in the cloud. A lot of these documents are super sensitive. We have our tax documents, we have our financial documents, legal documents, a lot of medical records. And I like to dig deeper. Who are the top users? Turns out Alex, Ben, and Cynthia, they own a lot of sensitive data. When I click on Ben, Ben is using a lot of cloud storage applications. Some of them are sanctioned, some of them are not sanctioned. And I can see in corporate OneDrive, Ben is uploading and storing a lot of our legal documents. So now with that, I have decent amount of visibility into cloud applications. I have decent amount of visibility into my data itself. It is time to take some actions. The first thing I like to do is I'm going to be a sledgehammer for all high-risk applications. Users should not be using a high-risk application like ZPShare. And I'm going to leverage Zscaler's Cloud App Control feature, simple policy. Create a Cloud App Control policy with high-risk profile and block ZPShare. And while I'm doing this, I will make sure our users are not blindfolded. They will be properly coached. They will be notified with proper justification. Next, if our users are using our instance of Office 365, they can do many different things. But if they're using our partner's Office 365 instance, I'm going to restrict their activities. And I'm going to achieve this with Zscaler's tenancy restriction. Again, a simple policy that says that when you are collaborating in partner's instance, there are certain things that you cannot do. Using tenancy restriction, I can also control someone's personal OneDrive and G Drive and other cloud storage applications. Next, it is time now to do some deep content inspection with some of the advanced DLP techniques that we have built. In today's world, the top 2 data exfiltration points are personal cloud storage application and email application. And I want to make sure that our intellectual property is protected. Our payroll has a sensitive CSV file. In that file, everybody's first name, last name, their bank information, their address is there. I'm going to index this document with exact data match. Our legal department also owns a lot of sensitive data, mitigation document, merger and acquisition document, and I'm going to index these unstructured data with index document match and document fingerprinting. And our HR and travel team, they have copies of everybody's passport and driving license. I'm going to classify this content with ML-based image recognition and OCR. So now, once the data classification is done, if the user is trying to upload these sensitive documents to their personal cloud storage application and email application, I will block them, but at the same time, client connector that is running on your endpoint will coach the user and notify the user. If you are one of those organizations where the communication is happening through Slack channels between the IT team and end user, you can use our Slack connector. You can coach the user, you can get the justification from the user, and you can properly log it. And if you want to use Microsoft Teams, that option is available as well. Okay, next, let's talk about Byod assets and unmanaged assets. Today, everybody is working from home. Once in a while, our users are using their personal asset, and they're connecting to my critical cloud assets, critical cloud application. Using Zscaler's identity proxy, we are going to intercept their authentication request, and once we identify the users are coming from unmanaged assets, we are going to isolate their browser session. When we isolate their browser session, then we can enforce a lot of conditional access on these Byod devices. We are not going to let them download any data. We can also block cut and paste and printing and various other activities. All right, so I have taken some actions inline. What about data at rest? When users are using corporate sanctioned SaaS applications, they're also uploading a lot of sensitive data in corporate OneDrive and G Drive and other applications. And one of the issues that we see, a lot of accidental data loss. Zscalers out of band CASB, we are going to manage this collaboration. If anybody is creating a sensitive folder and accidentally exposing that folder with a public URL or external link, we are going to block it. If users are trying to share sensitive data with external collaborators and untrusted users, we can restrict that behavior. And once again, while we are doing this, users will be properly coached, notified, so next time they do the right thing. And then the last thing that I would like to do is I would like to leverage our deep integration with Microsoft Azure Information Protection. As you know, a lot of data exfiltration happens inline. Inline, we can read AIP labeled documents and we become an enforcer. But for data at rest, we can do even better. As and when we are scanning these sensitive assets in the cloud, we can put an AIP label on these sensitive documents, and then Microsoft enforces encryption and rights management. So what we just achieved is the right people from the right device, from the right location, can access your sensitive data. Any unauthorized access will be restricted. So I have taken about 6 actions, inline and for data at rest, and all of a sudden I'm feeling better. It feels like that our data security posture has significantly gone up. And with that, I would like to thank you for taking the time, and you guys have a wonderful rest of the Zenith life. Thank you.
Thank you, Moinul. As a lot of you probably know, the Zscaler platform runs across 150 data centers. Now, why did we do that? We did that because from day one, our guiding North Star has been to make our stack be as close as possible to where users are and co-located right next to where most of the applications are. So we wanted to have minimum latency. So in that sense, the Zscaler platform has been an edge compute platform from the very, very beginning. And you're hearing a lot about Secure Service Edge now, which is trying to address some of those principles. One of the things that is happening with 5G is that compute edge is getting even closer to the user. And to give you a deeper view of how Zscaler's Zero Trust platform is a perfect fit and brings amazing security to 5G, I'd like to now invite Patrick Foxwen, Zscaler's Chief Innovation Officer. Patrick.
Thank you very much, Amit, and good morning. It's great to be back in person. I am sure all of you have heard the term 5G before. I think it's at the peak of inflated hype. And it's probably at the most in the consumer space because it's promising an awful lot. It's promising mobile broadband, ultra-high speed, low latency, massive scale. Another way of saying it's just quite good for video. It's almost spawned a whole industry of cellular providers. I won't call out any one in particular, but they have so many different terms for their flavor of 5G. 5G Ultra, 5G Plus, 5G Evolved or Evolution, 5G Ultra Wideband. There's a lot of terms for it, but what does this all mean for the enterprise? Because there is actually hype starting to form in the enterprise, and it's, of course, about everything that I just covered. It's about low latency, high bandwidth, scale. But there's another part of 5G that's coming along for enterprises, which is it's redefining the edge. Amit alluded to this a little bit in terms of there's new use cases, and actually the edge itself is evolving or changing. It's getting pushed out even closer. There's actually new terminology now around the edge that, the edge that we would call a couple years ago is no longer the same edge as it is today. I've got some examples at the bottom of some of the use cases. When you combine the ultra-fast, low-latency parts of 5G with a new edge, it enables a lot of new use cases at the bottom. So whether it's Industry 4.0 to AR and VR and autonomous or connected vehicles and all kinds of new use cases that it's powering. When I talk about the edge changing, though, this is what's happening. The edge is originally started in the data center. It's been pushed out now to the hyperscalers of the world. And what we're seeing happen in 5G and why it's very relevant to the enterprise is workloads are being rethought of at the edge, and the edge is getting pushed out further and further. There's going to be some terminology that we think that's going to come along with that, but one thing that we're seeing happen as this edge is evolving is the same things that we've seen companies do for moving to the hyperscalers of the world, the same problems are following to 5G use cases, which is a challenge. A lot of times organizations, if they're embracing things like private 5G, or they're thinking about new workload applications, what they should not be doing is just deploying yet more firewalls or more network-based security elements around 5G. And it's unfortunate we're seeing that happen. So this is why we're looking at the space very acutely, because there's new things that when I say the edge is evolving, here's a term MEC. There's things where the edge could actually be running in a backpack on a person, where compute is running locally. I'll show you an example of that. And so we're building solutions into this space. Here's some early preview of what we're thinking about, because in the 5G world, you have to rethink identity. You have to rethink how devices are connecting. And so we're allowing customers to build policies around devices. We're allowing zero trust access policies. Jay gave a perfect definition of it in the beginning, to be applied to 5G environments. We think zero trust is missing in 5G out of the box today, and we can help with that. And in 5G scenarios, things like latency can really matter. Like if you have an augmented reality headset that needs local image processing, if that's more than 8 milliseconds away, you're going to have motion blurring and sickness, and it's not going to feel real to people. And you have to prioritize that traffic in almost a hyperfine way, is the terminology we're using. You'll hear us talk more about this tomorrow in a breakout session. But I want to leave you with just 3 real-world examples, because I don't want to pile on to the 5G marketing hype. So here's 3 partner-customer examples of how companies are partnering with Zscaler in the 5G domain. If you're not familiar with Nokia, they are one of the largest private enterprise 5G organizations deploying 5G cores in the enterprise. Think of it almost as a replacement to Wi-Fi. We are operating in their cores today, and you're going to see a lot more coming from us there. Sandvik is a customer reference. Aside from making really cool-looking mining machines, which we're depicting here, they're becoming connected, and they need zero-trust ways to communicate. We're at the core of that with Sandvik. And my last reference is when I mentioned 5G could be running in a backpack. It literally is happening in tactical warfighter scenarios. So we did a partnership with Class. We're showing a picture of an actual 5G edge MEC that is running compute in that backpack, enabled by Zscaler, enabled by what we're doing in the 5G space, is survivable because in scenarios like this, and I'll extrapolate this out, it's not just a backpack, but it's lots of different things. In scenarios like this, you might not even ever be able to rely on the internet being connected or even the 5G private network being connected. So you have to have it survivable. It has to be offline, especially if it's running in things like vehicles or other devices that might be in the use cases that we're depicting here. So hopefully this is giving you a little bit of a view of what the edge is becoming in 5G, and you can guarantee that we're going to be in the middle of it with our Zero Trust Exchange. And so with that, I will send it back to Amit. Thank you very much.
Thanks, Patrick. Thank you, Patrick. I promise this is the last time you'll see me on stage today. I know there was a lot to unpack. There are plenty of breakout sessions where our product teams will go deeper into some of the topics that we covered today. Today was largely Zscaler for workloads. Tomorrow, we'll be talking about Zscaler for users, specifically how we are using our big data, machine learning, and AI to drive better security as well as better user experience for users. You can see some URLs for more resources around some of the things that we have announced today. I know it was a bit of a bladder test for all of you, so I appreciate the patience. We're going to wrap up soon. I'm going to hand it back to Chris Kozub. Thank you.